Hello everyone, my name is Razvan Dinu and I'm the CEO of RoboSelf. In the next 15 minutes, I will introduce you to a new approach to conversational AI and I will show you how we've built it into the RoboSelf platform. Our vision is a digital assistant for every employee, or a RoboSelf as we call it. Digital assistants are a stepping stone towards the ultimate goal, digital employees, which sits somewhere at level 5. However, building level 3 assistants and moving into level 4 is a complex process. To handle some of this complexity, we've developed a new approach which we call object-oriented conversational AI. So what is it? Object-oriented conversational AI is a conversational AI paradigm based on the concept of objects. Objects can have properties, relationships with other objects, and actions that can be performed with or on them. How does this relate to other existing approaches? Well, using a simplified model, any digital assistant technology has these 4 core components: natural language understanding, dialog flow, action execution, and natural language generation. Our approach also adds objects as a core component. The conversations and tasks a digital assistant needs to understand usually involve one or more business objects. Or looking at it from a different perspective, these objects and their links form a knowledge graph. And you can think of it as the memory of the digital assistant. Most objects will be domain specific, but some objects can be general, like an email, attachment, or file. Okay, this all sounds great in theory, you might say, but how does this look in practice? At RoboSelf, we have integrated the knowledge graph at the core of our digital assistance platform. Moving forward, we'll look at how we can build a digital assistant using this approach. As a working example, we'll use a merchant assistant designed to help local businesses affected by COVID-19 to sell online directly from WhatsApp. The assistant must help with managing the profile, the products, update the inventory, and track payments and deliveries. So, the first step is to define all the objects using a simple schema. We use a simple YAML format. For each object type, like business, product, order, we define their properties. Properties can have primitive types, like string, image, currency, number, or they can refer to other objects. For example, an order would refer to a customer, and an order item would refer to a product. The schema basically defines the structure of the knowledge graph, which, as I mentioned earlier, acts as the memory for the digital assistant. This graph is usually populated using a two-way API integration with the system that the assistant needs to interact with. And once the knowledge graph is populated, we can actually ask our assistant questions about the objects in the graph. For example, we can find out what delivery methods are available or the list of products in our store. Now let's continue with implementing a simple action for updating the stock of a product. This will enable us to highlight some key features of using object-oriented conversational AI. But just before we do that, let's look at the format we'll use to describe the natural language part. It's a Markdown format inspired by Rasa, but with 3 extensions. First, we use it for multiple types of symbols, like intents, objects, properties, or utterances. We support type parameters and argument patterns. What are argument patterns, you might ask? Well, when interpreting natural language input, our NLU engine will use exactly one pattern and 0 or more argument pattern. It can be a bit confusing at first, so let's see it in action. First, we define how we talk about the objects in the graph. For example, we configure how we refer to a product in natural language by using its name or special expressions like out of stock. You can notice the use of argument patterns here. This means that we can also use a combination of them, such as out of stock plates. We also configure how we refer to its properties, For example, we can refer to the price of a product using expressions like listing price or public price. We'll see why this is useful in a minute. Also worth mentioning that these are language dependent, so we'll have one file for every language we want to support. Next, we define the intent update product stock. It has three parameters: product of product type, quantity, which is a number, and extra, which is a boolean. We define a set of patterns like set stock to a given quantity for a given product. Now, the cool thing about object-oriented is that when defining an intent like this one, we don't need to include all the possible ways to refer to an object. This will be used automatically when training the model. And of course, we can also easily define expressions with a special meaning, like out of stock. Next, we write the actual code for the action, which is registered for the update product stock intent. Here we're looking at a simple Python implementation. It is important to notice that the action receives the object directly as a parameter. The robot self-natural language understanding is performing not only intent classification and entity tagging, but is also linking object entities to the actual object in the knowledge graph, which then gets passed as a parameter to the action. Last but not the least, notice how we've used the object when we've uttered a message. This brings us to the last step, how the assistant talks about objects and the actions it performs. We use the same format we've introduced earlier, but for utterances rather than intents or objects. Notice how we can use any property of an object directly from the utterance text. In this case, we're using the product name. Now, let's see it all in action. As expected, we can use any of the defined patterns to ask the assistant to update the stock, and the changes are reflected correctly. Okay, so far we've seen how object-oriented conversational AI can be used to model intents linked to objects in the graph. But there are many more benefits to the object-oriented approach. We'll briefly look at three of them now. First, we can define generic intents that work with any type of objects. They are somewhat similar to base class methods or templates in object-oriented programming. And the nice thing about them is that they work out of the box, saving a lot of development time. In this example, we can show the list of objects of a particular type, or we can update the property of a given object. And like with these two examples, we can change the name of a product or its price, or just show the list of my products. Through objects, generic intents, and generic actions, we can achieve a great modularity and reusability, which ultimately will help us manage some of the complexity in building level 3 assistants. Secondly, queries using natural language. Queries can be seen as a particular type of intent that return one or more objects of a given type. We already have a simple out-of-the-box query mechanism just by using the object definition. But we can also easily add new queries, like, for example, teaching the assistant to understand the query for sold-out products. As expected, both of these will work. Obviously, we can also go one step further and define generic queries, which will save even more development time. The third benefit we'll touch on is the context of the conversation. In this example, as you can see, we just say set stock to 10, and the assistant figures out to work with the object retrieved by the previous query. Using object-oriented conversational AI, we can intelligently match intents with the objects in the current context. An important topic to cover is, of course, the dialog flow. We are talking about conversational AI after all. Currently, we support three types of dialog flow. Direct, contextual, and action-driven. A direct flow maps an intent directly to the action that needs to be executed. We've seen this, for example, when we've asked the assistant a question. A contextual flow, on the other hand, determines the exact intent based on the context. And we've seen this in the example when we've asked the system to update the stock without specifying, again, the product. Last, we can encode any type of flow directly into an action. For example, if we wanted the assistant to offer to place an order for a product that is out of stock, it would look something like this. Notice how we can also invoke one action from another. Also, we're currently working on integrating machine learning-based flows using stories, so stay tuned. Okay, in these 10 minutes, we've only been able to look at the tip of the iceberg in terms of what object-oriented conversational AI is and what it can do, and in helping us simplify the development of digital assistants. At RoboSelf, we have developed a fully managed cloud digital assistant platform that uses object-oriented conversational AI. It is currently in beta, and we're going to look briefly at some of the key features we offer. First, we use a skill-based architecture, and we offer a Python skill SDK that can be used to easily develop and publish a skill. For example, using the RoboSelf command line interface, we can easily initialize a skill. And as we've seen earlier, the basic structure of a skill is very simple, including the markdown files for utterances, intents, objects, and queries, the Python code for the actions, and of course, the schema YAML files. It's worth mentioning that the markdown content can be split in any number of markdown files. This is very useful as a skill starts to grow and we're dealing with many different objects and intents. We can run a skill locally for development and testing, or we can publish it live. Either way, we offer a live robot self-chat interface to interact with the assistants for private testing or with real users. A key feature of the RoboSelf platform is our hybrid approach to natural language understanding. Firstly, we use natural language patterns for objects and intents to train a machine learning-based model. For this, we use Rasa behind the scenes. The machine learning models are trained with samples generated automatically using the patterns and knowledge graph. Secondly, we also configure a rule-based model that employs context-free grammars. Okay, why use grammar-based model in the age of transformers, you might ask? The main reason is that very short commands with just a few tokens can be highly ambiguous, especially when they include references to properties of objects. Change coffee mug price is one such example. For these cases, the machine learning-based entity tagger just doesn't have enough context to learn how to tag, especially with few samples. But a rule-based system can analyze all the possibilities and also integrate information directly from the knowledge graph. And its precision is 100% compared to machine learning models, which still sometimes fail. And actually, this hybrid approach enables us to even match part of the input using machine learning-based models and part using rule-based models. So, to wrap it up, the RoboSelf platform offers a fully managed environment that includes the hybrid natural language understanding engine, the knowledge graph, and the assistant and skill runtimes. We also offer channel integrations like WhatsApp and Slack. And last but not the least, we also offer RPA integration. This is very important for certain use cases, and currently we support UiPath Cloud Platform. Want to give it a try? If you're a SaaS company and you're looking to add a digital assistant to your product, please get in touch. Also, if you're a developer and want to test our Python SDK, do let us know. Who are we? My name is Razvan Dinu. I have a PhD in artificial intelligence, strong startup experience, and I'm a math and computer science geek. Traian, my co-founder, has a PhD in natural language processing, extensive research experience, and he's an associate professor at Polytechnica University of Bucharest. Feel free to connect with me or Traian on LinkedIn. We're really keen to help you build digital assistants for you or your customers. Thank you.